on what order your teacher decides to cover things in, this might be the very first topic for you for grade 9 in high school. So welcome to grade 9. It only gets harder from here. So this chapter unit has to do with something called polynomials. And I'm not even going to explain in this video what a polynomial is. We're going to take a few steps back because if you're coming into high school, you might be coming from a different school and different students may have learned things in different orders, but also different teachers may have done a better or worse job of telling you, oh, by the way, this is something you want to remember next year in grade 9. So some of this might be new, some of this might be old, and we'll come up to what a polynomial is, I think, in 3 or 4 videos. So we're going to rewind from polynomial to a simpler question, which is, what is a variable? And you probably sometime around grade 6, 7, 8, you started getting introduced to using variables. So variables is the very, very straightforward literal definition is a letter used to stand in for a number when you don't know what it is. And this is the thing that makes math so confusing, and it makes the difficulty level jump up into high school, is we spend almost all of our time talking about numbers even when we don't know what the numbers are. Now, you got an introduction to this, and the easiest thing might be a formula. So something like area equals length times width, right? So in this case, L and W are variables. They are standing in for numbers you don't know yet. And the reason we do this is because we want to separate into 2 separate steps. First, we're going to decide what we want to do with the numbers. Do we want to add them? Do we want to subtract them? Do we want to multiply them? Do we want to divide them? Do we want to do something more complicated with brackets and exponents? And we separate that part from the actual doing of the adding, the subtracting, the multiplying, and dividing. So by now, you're experts, addition, subtraction, multiplication, division, and even if you're not, you have a calculator or something which is with you all the time. So it's not that going to be that difficult, but really, this lets us be abstract. We can talk about what we're going to do with numbers even if we don't know what the numbers are. Now, why would you want to do that? Well, one reason might be that this is part of a collaboration. So maybe you are working on some kind of science project as a team. And so one person might be tasked with figuring out what the calculation is. One person might be tasked with collecting the data. So that might mean, going out and measuring the heights of the people in your class or rolling something down a hill and measuring it with a stopwatch. And a third person might be tasked with doing the calculation. So if I have variables, if I have letters that can stand in for numbers we don't know yet, I can do thinking about, okay, I want to take this and then I want to add or subtract or something. And I can do that thinking completely separate from the other members of my group, one person who might be collecting the data, and I can leave the calculating to someone else. This actually was a real problem in the olden days. I mean, you take for granted right now the fact that you have a scientific calculator that fits inside of your pocket, whereas calculators either used to be other people that you hired or they were machines that were the size of the room you're sitting in right now. So the ability to actually get, a good answer to something like what is the square root of 73, that was not something that was necessarily easy up until probably about the time when your parents were young. The other way to think about this is in terms of computers and software. So maybe I am designing a piece of software and I need to figure out what to do with some numbers that are going to come in later. And that person is going to put the numbers in later, weeks, months, years after I do my job. They might live in another country. I might probably never meet them. So you want to sort of have placeholders for numbers, because the person who will be deciding what the numbers are is, who knows where they are. You're never going to see them, and you can't wait until they decide, what their address is or what time they want to go to bed or whatever program it is that you're designing. All right, so here are just some of the conventions for using variables. Now, conventions are what you might call rules that we made up, but for good reasons. And a lot of this has to do with just being clear when you communicate with other people. So one of the major rules for variables is they're very often lowercase letters. Okay. The other thing is we use cursive. So if you're watching your teacher write on the board, you probably don't see them write the letter X like that. You probably see them write the letter X like that or like that. Right? And the reason we do that is because when you write in cursive, it means an X and a times sign look like different symbols. Now, the way you do that if you're typing on a computer is you don't use cursive, you use italics. So that's put the letters on a slant. Now, when I say you use lowercase letters, some special ones occasionally use uppercase ones, so things that are very important. So for example, when you're calculating area, the letter we use to stand in for area tends to be capital A instead of small a, or a capital P for perimeter. So there's all kinds of things that, just for accidents of history and whatever, we say they're mostly lowercase letters, they're mostly uppercase letters. Now, generally we tend to use letters from the end of the alphabet. So X is a favorite, so is Y, so is Z. Now, you do need to make sure you do something so you can tell your Z's apart from your 2's. So a Z like that and a 2 like that look a little bit too similar. Some people put the line in the middle. Some people do cursive Z's, except cursive Z's look like a 3. But just be mindful of your handwriting. If you really need another one, you use W. But the other thing we try and do is it's always nice to choose a variable which has something to do with the question you're asking. So X and Y are good generic mystery numbers, but for example, if I'm throwing a ball, I might be talking about the height of the ball and the time that it stays in the air. So H for height, T for time, that sort of thing. I might use P for price. Right? I might use L for length or W for width. So it's nice to get into the habit of, wherever possible, picking a letter that matches what's going on in the question, because it just helps you remember what's what. Now, this gives, you're going to notice a problem about that right away, which is running out of letters. So let's say I'm doing something which is maybe has a bit of a sciencey feel to it, but doesn't matter. So I'm going to measure the heights of 5 people in the class, and I am going to calculate the average. And the way you calculate the average is you do the first number plus the second number plus the third number plus the fourth number plus the fifth number, and then you divide by the number of numbers, which is 5. Now, if I'm using good form, good communication in variables, these sort of blank spaces are no good. So I want letters. Now, the first one, H is a good one for height. Now, what comes next? Well, one argument is that I should keep using the same letters in alphabetical order. So after H becomes I, and then J, and then K, and then L. But what happens if there's lots of students and I want to do this with lots of people and I am going to, I'm going to run out of space. So we have a condition to get around that, and we have a way of labeling using what's called subscripts. Subscripts, yep. And so what I do that is the first height is height number 1, and the second height is height number 2, and the third height is height number 3, and the fourth height is height number 4, and so on and so on and so on and so on. And now I can have as many heights as I want because I can run out of letters of the alphabet, but I don't run out of numbers. So this could keep going, and this could be, I could do the entire school. I could go all the way up to height 563. If that's the number of people in your school, that was a lucky guess, I swear. So that's the convention we use. If we're afraid of running out of numbers, we can reuse the same letter over and over again. And when you put a little subscript, we usually call this the index. Just be careful that that's not the only thing we use small numbers for. So if I put a 2 up here, remember that means squared. That's h times h. So you don't want to get those two confused. So very brief overview of just variables, and I think that's probably mostly review, but we'll work up to something a little bit more complicated very shortly. So see you soon.